Now the most important assumption is that error term has a zero mean. Error term has a zero mean. Okay, so what you're trying to do is that you have certain x, okay, for that you generated some y population, okay, with certain distribution. You did this for several x and you calculated this, okay, and then you join them together. Okay, sorry, it should get through this peak. Fine. So and each of these x's, each one of these are centered around the true value. Okay, so here the errors here around this line, the line which you want to fit here, errors have zero mean around the line. Here errors have zero mean around the line. Okay, so errors may have, in case if the errors have sort of non-zero mean, okay, what would you try to do in that case? Supposedly errors have non-zero mean, okay, then you would want to fit a different line. Okay, I'll tell you how. Supposedly if you have peaks which are below this, okay, you initially, supposedly the corresponding to this line, okay, I'm drawing this line, which is this, okay, but ideally your errors, they have a mean around these points, okay, which are below, so you would want to fit a different line, okay, where errors would have zero mean. Fine. So then you would fit actually this line around these points. Clear? Well, this may look a bit clumsy, but I hope that the idea is actually clear. That errors have the zero mean. Geometrically, this would actually mean this, that for a given x, there is certain y population, okay, which is distributed around its mean value here, okay, as you can see out here, and with some y values, of course, they are above, and some y values which are below the mean value. Okay, the distances above and below the mean values, they are the residuals. Okay, the distance above and below the mean value, they're nothing but the residuals. All of these are residuals. These are your residuals, the distances which are above and below. And what it requires is that on an average, these deviations should be equal to 0. Okay, on an average, these deviation should be equal to 0. So in nutshell, what this assumption is saying is that if you have the model which is y is equal to beta 1 plus beta 2 xi yi equals plus ui, it is trying to say is that the factors which are not included in this model, okay, say the factors which are not there in the model, say you are trying to judge income which is made as a function of education. Okay, so the factors which are not included in the model. Apart from education, there might be hundreds of other factors which are affecting income, but you will assume this, that they do not systematically affect the mean value of y. Okay, so they are not affecting the your dependent variable, that is the factors which are other than education. So all the other factors which are apart from education, they are included in this error term, and you are assuming this, that on an average this error term should not be affecting this y. Okay, because in case if this error term is affecting this y, then what is the point of running this model? Okay, so you're assuming that income is dependent upon education, so this is the only thing. Okay, so this is what the assumption is. Thanks.